Well, welcome to all you hearty souls who were not put off by the weather. Washington people tend to be put off by weather, so I'm really glad to see all of you. Welcome to the second Math Ignite. This is a night to celebrate mathematics, which not many people do, but we do. It's a night to share ideas with other people who teach mathematics and to make connections. One of our purposes certainly is to make a community of mathematics teachers in the city, people who can support each other with ideas, with advice, with hand-holding when necessary, as indeed it sometimes is. I think most of you, looking around at the faces, know where you actually are. Is there anyone who doesn't know where you actually are? Put your hand up and I'll tell you. So you all know about the Carnegie Institution? Oh, there's a hand. Max. Okay, you want to hear the story? Or? Okay, so this is the Carnegie Institution of Washington. It was founded in 1902 by Andrew Carnegie, who was a very, very, very wealthy man, although he started out in the middle of the 19th century penniless as an immigrant from Scotland with his family. But through the dint of his high intelligence and ability to work very hard, he made a huge fortune. But he believed that people who had a lot of money should not die with it. So we had a program for giving money away. And the first thing he did was to found hundreds of libraries all over the United States. If a community was willing to buy the books, he would build a building. And there are many towns still that you go through, and you will see a building that is called the Carnegie Library. We have one here in DC. It's no longer a library. It's down on Mount Vernon Place, if any of you have gone by there. Anyway, then he started founding institutions, and he founded 22 different institutions for different purposes, and this one was founded to do research, which was interpreted to mean basically scientific research and education. And until about 1989, all of the education was advanced education in the sciences. People came to the Carnegie laboratories, which are not in this building, and most of them are not even in this city. People came for advanced training in the sciences. But in 1989, we realized that the institution had not done anything for the city in which it existed. So we started what we call the Carnegie Academy for Science Education, or CASE, and we've had over those years a series of summer institutes training teachers to teach science, and we have a Saturday science school for middle school kids who go to public schools in DC. And then in 2009, we decided to start Math for America in DC. It had begun in New York a couple of years earlier. And as most of you know, our main function is to recruit young mathematicians who would like to be secondary school math teachers. And a whole bunch of those that we recruited are sitting here tonight, and we're proud of them, and they form a kind of core for a community of math teachers in DC. So that's why we're here, and we're here to share ideas for teaching mathematics, share problems, whatever all that you want to share with one another. And I am going to sit down and turn this over to Will Stafford. What happened to you, Will?
Right
you disappeared, you're right there, who is going to carry on. Will Stafford is one of the Math for America DC master teachers. He provides professional development and also provides a model of an excellent mathematics teacher for the Math for America Fellows who are in training or just beginning to be math teachers. So Will, okay.
All right, thank you, Maxine. Okay, good evening and welcome to the second DC Math Ignite. Thank you for braving the cold and snow. As everyone not from DC or from Chicago, like I am, is amazed every year when the snow comes to DC and how we handle it. But I worry that I'm losing my Chicago toughness. Even I hope for the 2-hour delay or the day off. But it's good that you all made it out here. We're thrilled you could come out and join us as we continue to share ideas and enthusiasm around teaching math in Washington, D.C. In August, we ran our first DC Math Ignite and had a wonderful time. There was a palpable excitement in the room about trying to improve our teaching and bring that enthusiasm back to our classrooms and our departments. We're at the halfway point in the year, and perhaps enthusiasm isn't as strong as it was in August. That's why this is a great time to get a boost of energy going into the second semester. Some of us have new classes starting with the new semester, and some of us just have classes that are in need of a new start. And so tonight our goal is that you can get one idea to ignite a new energy in your classroom. We have an outstanding group of presenters tonight, and they're covering a wide range of topics. So this promises to be a great chance to get a lot of different ideas for you to take back with you. Throughout the evening, we're going to be handing out some prizes to you for you to take back to your classrooms. We spared no expense in getting these prizes, so you should be pretty psyched about the great swag you could bring back with you today. There are some prizes that even cost over $6, and so be ready for that transformative experience in your classroom. If you're new to an Ignite talk, here's how it works. Each speaker gets 5 minutes. They have 20 slides. Each slide is 15 seconds long, and that's the standard format for them to present their idea to you. In between presentations, we'll give out some prizes. We're going to do a little math midway through just to make sure that we're all practicing our math as we have our students practice while the other speaker gets set up. We'll give out prizes while the other speaker gets set up. Midway through, we'll all do some math. We've asked each of our presenters here to reflect on an important question that comes up this time of year, and that's what's your go-to snow day activity? As you know, it's against every teacher contract for you to do work on a snow day, and so it's important that you have another plan in place when you're sitting at home. So just to get the night started, if you wouldn't mind turning to somebody next to you, if you don't know them, introduce yourself and just take a minute to tell them what's your go-to snow day activity. Okay, thank you all for driving right into those introductions. We're going to go ahead and get started with our first presentation. Our first presenter is Max Olivier. Max teaches at KIPP College Prep and is a Math for America Fellow. When asked about his favorite snow day activity, Max said cooking breakfast and reading on the couch. His presentation is timely. It is titled Counting Superbowl Captains. Let's give a warm round of applause for Max.
There we go. Hello, everyone, and thanks to Will for organizing all this. So, as Will said, I'm Max Olivier, and today I want to talk to you about counting Super Bowl captains. So, the inspiration for this idea is due to one man, who you've already seen his picture, this guy here, Joe Namath. For those who don't know, Joe Namath did the coin flip at the Super Bowl last year. And what amazed me most about the coin flip at the Super Bowl is not so much his coat, though that is spectacular, but more so the sheer number of people that come out to a Super Bowl coin flip. So if you look here, this is from the 2013 Super Bowl. In addition to like all the members of the media, which there are tons, and you expect that each team has like 5 captains there. I think the 49ers have 5 and the Ravens have 5 too. So of course the natural question is, well, how many ways are there to pick those 5 captains? Right? If you've got 5, there's got to be a lot of ways to pick them. Turns out, when I was watching the Super Bowl, I was also teaching counting problems at the time with my statistics students. And I thought, this would be a great question to have them answer. How many ways are there to pick the captains for a Super Bowl team? The week before the Super Bowl, we had really talked about 2 main ideas that I think are kind of prerequisites if you're going to be able to answer this question. So the first is the multiplication principle, which many of you might be familiar with, that if you have A ways to do one task and B ways to do another task, and the tasks are independent, then there are A times B ways to do both tasks. The second idea, which I think probably isn't as common, is something called the labeling principle. Now, I can't take credit for that name. It's actually due to James Tanton, for those of you who know him. If you don't know him, look him up. He's a great mathematician and math educator that has a lot of really good ideas. Oh, it didn't come out. So, labeling principle, this should be n factorial over k1 factorial, k2 factorial. It's just a multinomial coefficient. But Tanton's idea, which I think is a really good one, is that permutations and combinations, when we usually teach them, the distinction can be really difficult for students, and that the labeling principle gives us a single way to teach permutations and combinations at the same time, so that we don't have to make this distinction. Students can just use that principle to answer. It's something I'd really encourage people to look into when teaching it. So the first question I ask students, we do this as a discovery the day after the Super Bowl. I've got my little corny introduction there. I always have to have that. But the main part of this question is, so how many ways are there to pick 5 captains for an NFL team, assuming as there are 53 players on a NFL roster? And as many of us know, the answer to that is just 53 choose 5. So, or 53 factorial over 5 factorial, 48 factorial. I usually have my students write it in factorial form in keeping with the labeling principle. So from this, we answer a more realistic question, because the captains usually aren't just 5 random players. Usually you have some from offense, some from defense. So I ask students to figure out how many ways are there to choose 3 from the offense and 2 from the defense. And we break this up into parts. We first ask how many ways are there to choose the offensive captains. And I give them a number, say assume there are 25 offensive players on a football team. And then we pick the defensive captains, and then we can use the multiplication principle to figure out how many ways there are to choose 5 captains overall. Now, the wonder or what I like about this question is it then opens up a whole door to a bunch of other questions we can answer, right? Because the idea behind that question lets us answer, hey, what if we want 2 captains on the offense and 3 on the defense? Or if we want some from the offense, some from the defense, some from the special teams? You can put all sorts of restrictions on this, right? What if you can only have starters? What if one has to be a starting quarterback and one has to be a starting linebacker? You can have your students come up with their own variations of this. And they're all around the same question, just like picking 2 from the offense and 3 from the defense. So the reason I like this lesson, it actually became one of my favorite lessons of the year, is twofold. First, I think it's just a fun way to practice counting problems. Like I said, we had looked at some basic principles of how to solve counting problems, and this gave us a nice way to apply those. And the second reason is that I think it gets at something I'm sure a lot of us try to emphasize with our students, which is math really is everywhere. Even in a problem that we might not see any mathematics, right? These 2 groups of big guys coming out for a coin toss could actually ask a lot of deep and interesting mathematical questions about it. Well, thank you very much.
All right, thank you, Max, for getting us started. We are going to do a little raffle between each round. Tonight's first prize is a set of giant dice for you to bring back to your classroom. They are 6 inches. There are 2 of them. They are soft. The advantage is that it's a great way to do some random cold calling, some probability, a fidget for students to hold, something colorful for your classroom. So if you have raffle number 108, you are our first winner. 108, all right, great. Okay, our second presenter tonight is Ellen Whitesides. Ellen is a former math teacher who currently helps run Illustrative Mathematics. When asked about her favorite snow day activity, though she doesn't get to miss school now that she's out of the classroom, when it gets cold, she likes to go ice skating down at the sculpture garden. Her presentation is titled Mathematical Structure. Let's give a warm round of applause for Ellen.
All right. Mathematical structure has been getting a lot of press recently because it's one of the standards for mathematical practice. And I spend a lot of time talking about the Common Core because I work for Bill McCallum, who's one of the lead authors of the Common Core. Together we have a nonprofit organization called Illustrative Mathematics, which is a discerning community of educators dedicated to the coherent learning of mathematics. But what does structure actually have to do with mathematics? And why is it useful to students? Why are our students going to be better mathematicians if they can look for and make use of structure? Well, according to Webster, structure is the way that something's built, arranged, or organized. And it could pertain to people, like how is your team structured, or it could pertain to the entity, like the Burj Khalifa is the tallest structure in the world. According to Wikipedia, structure is a fundamental notion, either tangible or intangible. And I can imagine a tangible structure like a bridge or a snowflake, but an intangible structure, that's a little more difficult, maybe like a function. And when I think of structure, I think of this shape sorter. So kids take the little shapes and they try to say, okay, does this go in the triangle hole or the rectangle hole? And they're looking at the structure of the shape and deciding how to categorize it based on that structure. So why is it helpful to know something about structure? How does this examining and classifying help our students? When I was a high school math teacher in New Orleans, I had a lot of students that knew how to solve problems quickly. I would give them an equation, they would solve for x. They would find the zeros in, they would have a quadratic function. But oftentimes these students that could do the procedures of mathematics so quickly faltered when trying to figure out whether they had answered the question. Had they finished? Should they plug something back in? They were really good at the doing part of mathematics, but they couldn't really determine what to do or whether they were done or if they had done it. So that part of mathematics is actually a really important part of mathematics, and that's where structure could be helpful. Students that can see structure in mathematics can look at an equation with an ugly number and not be nervous. Instead, in their head, they know certain things about that equation because of the hole that it fits into in the shape sorter and the other equations that are like it. They know something about the expressions that they can generate, and they know how they relate to the specific context. So in this context, we're looking for a maximum height. Which expression could help us find the maximum height? If you look at this part that's squared, we know that's positive, and it's multiplied by a negative number, so we're always subtracting something from 100 over 16. So at any time, any value of t where 100 over 16 is going to have to be the maximum. Students that can look for structure can look at different expressions and relate them to a context. So here we have a pool, and we have the tiles around the pool, which are 1 by 1 feet, and we have S by S in the middle of the pool, and we can demonstrate these expressions as different iterations around that pool. And since they all cover the pool exactly without overlap, we can demonstrate that these expressions are equivalent to each other by using the structure of the expressions and the structure of the geometry together. So how do we move our students from those that can do procedures quickly, build on that knowledge, to students that can sort and categorize the equations and look for the structure within mathematics to be really successful? What if we add to the types of tasks we ask students to do? We give students equations, but we don't necessarily ask them to solve the equations. Instead, we give them different forms of an equation and ask them about what would be best for a different situation. Or we ask students to compare them to context. What if we gave students like a problem like this, where X and Y are the amount that 2 trucks can hold, and S and T are the number of trips each truck is taking, and then ask them, what do these expressions mean in the context of that problem? What if we, instead of asking students to generate equivalent expressions, gave them the equivalent expressions and asked them which one is most useful if this is what you want to find? If you want to find the profit when the price is 0. What if we we ask students to compare different expressions, just simple expressions like these, but not by calculating, by looking at the structure of those simple expressions and deciding which one is larger without making calculations? What if we gave students a simple expression like this and told them one of the variables was increasing, but didn't ask them what's happening to the whole expression, but what form would you put the expression in to decide what's happening to the whole expression? So we want our students to look at patterns and relationships of entities, but we want them to do this through classification and use this to not only solve for X, but understand what they're solving for, know when they're done with the problem, and understand the math we're asking them to compute.
All right, thank you, Ellen. All right, we're going to give out another prize here. The second prize tonight is 5,100 stickers. This prize is not for those jaded fourth graders, but for the sophomores and juniors and seniors who crave a sticker to motivate finishing that assignment. And our high school teachers understand the power of a sticker, all the way up through my seniors in calculus. So our winning number for this prize is 133. All right. Okay. Our next presenter is Erika Hedin. Erika teaches at Capital City Public Charter School, and when asked about her favorite snow day activity, though ambitious, she said, a hike through Rock Creek Park followed by grading. Erika's talk is titled Transparency in Math for Self-Directed Learners. Let's give a warm round of applause for Erika.
So this year at my school, Capital City, teachers were given a chance to direct our own professional development. Our coach and principal pitched this new structure at the beginning of the year by sharing lots of research about how much harder people work when they feel ownership over determining what areas they need improvement on. Well, I bought into this idea. Oh, do I have to click this thing to make it start? Yeah. All right. There. All right, well, I bought into this idea, and I started to reflect on the fact that I should share this motivational feeling with my students. So now the question is, how do I help my students see the areas that they need to improve on? How do I help them take ownership over their own learning? The answer that I came to was transparency. Students need access to their own data. That way they can see clear, targeted areas in need for improvement. And then they need structures that support improvement. Many of us already put learning targets all over our rooms. Though our schools may mandate this, it does have the purpose of letting our students know the purpose of our lessons. I even write learning targets on their assignments, or rather all the assignments that I can remember to when I'm standing at the copier. Short-term learning targets are grouped under long-term learning targets, and then long-term learning targets average to make up the course grade. But to go beyond just letting our students know the purpose of our lessons, we also have to involve our students in the other job of teachers, the assessors. We have to involve our students in understanding where they are in the progression of learning. My first step in this process is to push my students in their thinking about progress and about success. I talked to them about the fact that if I gave them all of the 6th grade assessments today, they'd fail. They haven't been exposed to the content yet, and so they haven't reached mastery. And that for many topics, it doesn't take one-time exposure to reach mastery. It takes repeated exposure to different scenarios and constraints to be able to really demonstrate that they've mastered a skill. So we use learning target trackers to name where we're at the beginning of a lesson, to where we're at the beginning, middle of a unit, and then where we're at the end of the unit, and then again at the end of the year. And then we start talking about grades. All of my students' grades are standards-based. We use a program called Jump Rope. It costs money for a school, but my school's bought into it. But individual teachers can also use it for free. Jump Rope has been great for my students to move away from expecting one overall grade to being able to see that, especially in math, there are so many discrete skills that must be mastered in order to be on grade level. By looking at these pretty green, red, and yellow bars, my students can see what specific areas they need to work on and what areas they've demonstrated proficiency on. I've created, as well as borrowed from amazing colleagues, so many different reflection worksheets. I'm still in search of the perfect one, so if you think you have it, I'd love to have it. The major keys that I've found in good reflection worksheets, ones that really move students to understand what they still need to work on and why, are worksheets that explicitly state the learning target and give space for reflection. I'll also acknowledge that I'm a middle school teacher, so my students' needs for reflection are a bit different from elementary and high school teachers, but even that being said, everyone needs to be given a chance to reflect on what we've done well and what we still need to work on. So once my students see these bars, I want them to know that they can keep working, keep building, keep improving. which means they have to work. I plan reteach stations that name the learning target. That way, my students can self-select into the group they think they need to work on. Though I will admit, there are definitely students who I tell where they're going to be. I plan opportunities for spiral review by intentionally inserting learning targets from previous units into do nows and exit tickets. And then I keep assessing. I keep recording student performance on classwork and tests, and I add this to the jump rope database. There's so much data, it's insane. And in this way, the grades are more than grades. They're just a statement of where my students are right now, not where they'll be forever. Their grades are transparent, they can be moved through. So grades and tests, hopefully, are impermanent in the way that each school year is. My hope is that I've given my students the belief that their current station is not the one that they'll be in forever, that they can move fluidly through the experience of math class into other experiences. One year might be easier than another, but they can see that through targeted efforts, they can grow themselves. And in that way, my students take ownership over their learning.
All right, thank you, Erika. Our next prize tonight is a set of math quotation posters for you to put up in your classroom or outside. Perhaps you have an overambitious English teacher who has a bulletin board next door to you. Now you can add 15 quotations about the power of math and algebra to one-up them. So our next prize goes to number 118. All right, congratulations. Look at those gems. Okay, we're now going to transition to a little math. I'd like to welcome to the stage Bill Day. Bill teaches at Two Rivers Public Charter School and is a Math for America master teacher, and he's going to get our brains working this evening. Let's give a warm round of applause to Bill.
Okay, guys. You got an other notes section on the back of your note catcher. Take a look at this problem. We're going to solve it. This is an AMC 8 problem. It's a competition put out by the Mathematical Association of America. Sorry. We're also going to try to do a little technical, thank you, little technical magic where I'm going to use my iPhone as a document camera. So if you have some nice work on there, as you're working on this, I'm going to come around and try and get some video as you explain it. Okay? So go ahead, take a few minutes, look at this problem. All right, if you have a solution, you'll see some hands, and we may get some video of your work. All right, this is FaceTime. So I called. I don't get a lot of calls, so I had to call myself through FaceTime. All right, so Cody, tell us about this. I know we're getting some audio through the microphone, so I'll try and repeat some of your salient points.
Okay, so there were along one side there were 32 toothpicks.
Okay, along one side there were 32 toothpicks.
And then if I start at the top of the first toothpick, that corresponds to a row of 60. And
Okay.
the second toothpick, there's another row of 60.
So
Keep on going. There's going to be one of those rows for each of the 32 toothpicks. And there's going to be one more row at the bottom. So that is 33 times 60 here on the left.
Okay, so the horizontal lines, you're saying there's 32 of them, and each line has 60 in it, but there's also an additional line on the bottom. So 33 total horizontal lines of 60 toothpicks each.
Right, and then using similar reasoning, there would be, looking at the vertical lines, there would be 61 rows of 32 toothpicks.
And then for vertical lines, there would be 60, and then one extra on the end. Each of those vertical lines have 32 toothpicks in them, which lead to two multiplications. 33 times 60.
33 times 60, 33 times 61, get 1980, 1952. And the sum is 3932.
3932. Anybody agree with that?
Yeah.
All right. Will, you want to do another one, or should we move on?
Do you want to do one more question? Yeah. Let's do one more question.
All right, we'll do one more question. If we could switch back to the slides for a second.
Was that right, Phil?
Ooh, this is. So I do problem-based tests with my kids all the time, and they get really frustrated with me. We build the right answer through consensus. So, all right. So this one's really interesting. I'll read it as well. A certain calculator has only 2 keys, a +1 key and a ×2 key. When you press one of the keys, the calculator automatically displays the result. For instance, if the calculator originally displayed 9, if you pressed +1, it would display 10. Then if you pressed ×2, it would display 20. So when the display starts with the number 1, what is the fewest number of keystrokes you would need to reach 200? Go ahead and think about that. All right, guys, we'll take another 30 seconds. Is there anybody who has a solution now that they feel comfortable sharing? And maybe a visual of it? Okay, tell us about how you approach this problem.
So I figured I would have to double a lot.
A lot of doubling.
And I tried.
Sorry.
I tried doubling 2, and I tried doubling 3 as well. I thought it would be nice if I could get to 100 rather than going to like 192, which would take me 8 more steps. So the first time I doubled 2, ended up with 128, which wouldn't be helpful at all. Because before wasn't helpful.
Oh, so the first one didn't work out. Doubling didn't work. And the doubling 3 didn't work out as well.
So then I just noticed, I messed up completely.
Messed up? Not.
30 to 99. That was very helpful.
She pressed both buttons. But so one thing that I will say, Will, and maybe we can get this. She was working on a build up strategy, starting with 1, figuring out which way to get up to 200.
All right, it was building up.
Either another solution or another solution strategy. Okay, come on back here. Should I look at this part?
Well, this is really the answer right here, but then how I got to it was I started at 200 and I divided by 2. And so then I built back to see if 25 is where I needed to then basically subtract 1. So then I started going back. I got 3, and then I decided I needed to add 2 plus 1 to 3. Then I put 4.
All right. And so 9 steps. All right. By consensus, did anyone else get 9? All right. All right. Thank you, Bill, for helping us get some math in tonight. Okay. For high school teachers, if you have some students that you think would be interested in problems like these and you have not signed their kids up for the AMC 10 or 12, those tests are coming up in February, and it's a great way to get a small cohort of kids to sign up, take a test. I think it's February 25th is the second one, and it's a lot of fun, and they really enjoy it. So a great way to build a math community in your school. Okay, we're going to transition back to some presentations. First, we're going to give out one more prize. Another encouraging student work, it is a Facebook stamp. There is no way to show your kids you are up with the times like getting a stamp that stamps a like button onto their work from Facebook. Really encourages them to get their work done. This is a hot commodity in a classroom, and it's a thumbs up, but you can put it thumbs to the side. We need to work a little harder. Thumbs down. I am not liking that work. If we go forward one slide, I think we have a picture of this. This is a high quality work. Yes, all right. 139. 139. All right, great. All right, our next presenter is a virtual presenter. We wanted to invite someone from outside of our DC community to present, and so we asked for Franz Davis, who is a teacher in Texas, and she is a big presence in the math, Twitter, blogosphere, online community, and she's done a lot of excellent work and is an award-winning teacher who has a real interest in education technology. She gave this talk at the NCTM in New Orleans National Conference last year, and it's put on by the Math Forum, some folks that have helped us organize our events. If you are attending the Boston National Conference this year, they're going to put on another Ignite Night. I encourage you to go. It is a really great time, and there are a lot of great voices there. So we're going to watch her talk titled Teaching to the Kids in the Back of the Classroom. Okay, continuing with the theme of the online math, Twitter and blogosphere, our next prize is a book called Nix the Tricks, and it is a compilation of different math tricks that students have learned at some point that we all like to say from their former teacher, because we would never teach them something that would be a shortcut pedagogically. And so it's a great set of different discussions of why you shouldn't teach certain tricks. The great news is you can buy this book off Amazon. The bad news is I bought it the day before the second version came out. And so there's another one that has just come out that you can buy as well. It's put out by a woman named Tina Cardone, who teaches in Massachusetts and is a frequent attender of Twitter Math Camp as well as the Park City Math Institute, and is a really reflective teacher. So the winner of Nix the Tricks is number 115. All right. Okay, our next presenter is Max Mikulec. Max teaches at McKinley Tech Senior High School, is a former Math for America Fellow and current Math for America Master Teacher. When asked about his favorite snow day activity, he said catching up with Real Housewives of New Jersey. Max's presentation is titled The Benefits of Playing Chess at a Young Age. Let's give a warm round of applause for Max.
Thank you, Will. When Will asked me to do this talk, I wanted to do something that I really cared about and was kind of the highlight of my day and my week. So I've been the chess sponsor at my school for 4 years now, and I didn't really have any experience going in, but I've learned a lot in the meantime. I decided to make a warm-up. Those of you who play chess in the audience, the best move for white, and your white is moving up on the board. So this is just some things that I do with my chess students, try and get them engaged to make sure they have puzzles to solve. For this talk, I'm going to mention some skills that chess develops. I'm going to provide some data, some personal successes that I have had, and also how you can foster the chess in your classroom, just some takeaways. So Benjamin Franklin wrote about in his essay, The Morals of Playing Chess, the importance of a lot of things, but specifically the three that are listed here. How you need to be able to see all possible outcomes, not make decisions too hastily. He also talked about the importance of upward mobility. Don't be discouraged by how things currently are. How can you get out of the situation you're in? How can you make things better for yourself? And all of these are things that I think are important as you become an adult. Chess also helps kids practice visualization. I think the most important thing on here is planning and developing long-range goals, things that I don't really see my students do very often. But again, all these are things that are important for kids as they become adults. I found some data that showed in a study that critical thinking skills for chess students rose at a much faster rate than non-chess students, and also creative thinking, so both critical and creative thinking skills were rising faster with chess students. A district in Canada decided to use chess to teach logic to their students from grades 2 to 7. And again, problem-solving scores rose much faster than they had anticipated. So chess makes kids smarter. Again, more studies showed that chess improves these qualities. The one that I want to highlight is concentration. That's one that I'm going to speak about in a couple minutes because I've had a personal success with that. In the math classroom, chess promotes logical thinking. And also, like I said earlier, combines the analytical and creative thinking parts of it, which I think that the real good mathematical thinkers aren't afraid to combine those two ways of thinking. So a successful chess program that I visited actually in New York City is IS 318. They have a dedicated chess teacher. It's a middle school, and they've had multiple national championships. And they also have a documentary about them called Brooklyn Castle. And I kind of use their model to model what I'm trying to do at my school. We have much fewer students, but they're dedicated. I did recently have a student qualify for a national tournament in Phoenix, Arizona. So that's coming up this summer. So this is me, as you can tell by my glasses that I was good at math. But I was also extremely hyperactive. And as an adult, I was diagnosed with ADHD. Adult me used chess to really help with my focus and my concentration. And especially as a teacher, helped me realize how to plan ahead. And I really thought that I would have been a perfect candidate to have chess in my life when I was younger, to really help with those at a younger age. So, as teachers, what can you do? Look for students that kind of fit that same bill. They're intelligent, but they maybe are under challenged or hyperactive. Try and introduce them to chess. The U.S. Chess Center, for example, offers free lessons on Sundays to all DC students. What can you do? Well, if you want to directly foster that interest, play chess, get better at it. This book right here, Bobby Fischer Teaches Chess, it's very easy to read. It's one of the ones I give to my students right away. And I'll go on YouTube and watch some videos. There's some good videos on strategy. As parents, encourage your kids to try chess. They don't have to be masters, but they can learn some really good life skills just playing. It can also help with self-esteem and social skills. I've noticed some of my more withdrawn students, it really helps them socially. If you have any questions or interests in starting a chess program, my email is here, max.mikulec@dc.gov. Or you can just speak to me afterwards and I can just give you advice or put you in contact with someone that may be able to help you start a chess program. In this puzzle here, you may be thinking that the best move is to promote the pawn to queen, but that would create a stalemate. So that's literally the only way to win this puzzle is to promote your pawn to a rook. So if you saw that, I just wanted to make sure that you knew the puzzle. So my final tip, expose kids to chess early in life, but not too early. So thank you.
All right, thank you, Max. Our next prize tonight is a graph paper stamp. You can, copier's broken and you are panicking, take out a blank sheet of paper and a stamp pad and you've got some coordinate axes. Or have a student who's doodled a line on his arm and stamp his arm and talk about the math of that equation. Really great opportunities for learning there. Our winner is number 110. All right, our next winner is 119. 119, all right. Wonderful. Okay, our next presenter is Kirk Walters. Kirk is also a former math teacher who currently works for the American Institutes for Research. When asked about his favorite snow day activity, Kirk said, "When I taught in California, we never had one, and now as a researcher, I work." So our sympathy goes out to him. Kirk's presentation is titled Improving Student-Centered Math Teaching Through Collaborative Experimentation. Let's give a warm welcome to Kirk.
Do I actually get to say start? Is that allowed? And do I touch something or just do the thumbs up with my own thumb? Unless, could I borrow the thumb stamp? Well, thank you for having me. The title of my talk is way too long, especially for this style of presentation, but I work for the American Institutes for Research and I do math education work. And I think I'd like for you to ask yourself if you think that the state of math education in the United States is half full or half empty. I don't know. You guys are good with fractions. What do you think? Is it half full or half empty? I think there are a lot of people out there who would say it's half full. You have, unlike when I was teaching math in the 1990s in California, where we were making up our own stuff, we didn't have state standards that were aligned to high quality assessments. We were kind of just winging it. Things are better now. We have world-class standards. We have real assessments that I think are actually going to happen this spring. You have targets. You also have instructional resources that are better than the ones that we had back in the day. They're easy to access. Interesting problems that you don't have to create on your own. These are just a few examples of what's out there. You also are not teaching in isolation as much. There are new technologies that break down the classroom where you can watch other teachers teach more easily. Your kids can project their answers on a smart board, even text their answers on a Promethean board. And yet we know that there are lots of challenges. Teaching math is still incredibly hard, especially teaching for understanding and getting the kids in the back of the room to really apply themselves and do more of the heavy lifting and thinking. And the higher standards, quite frankly, make it harder. Some of the challenges are, to be successful, we need to know more about implementation context, expect variation in classrooms, as opposed to looking at average impacts, which is an important part of research. Let's find out what more happens in each classroom context. Jimmy Fallon fans out there, I want to say thank you to the Nellie Mae Foundation that sponsored a study that was looking at student-centered math teaching, which I think is a construct that's very broad and helpful, but in a lot of ways it doesn't get down into the weeds to understand what that really looks like in classrooms. And we ask, are there differences in student-centered approaches? Are there differences associated with students' engagement and achievement and problem solving in this study? We used a mixed methods design where we recruited highly regarded teachers to participate in this year-long study. We developed measures, surveys, collected video data to try to understand what, in fact, student-centered math teaching really is and isn't. We found some positive associations with kids' engagement in math and their success on the PISA problem-solving assessment. So there was a stronger association. Whoa, I think that's weird. That one was supposed to happen earlier, but I can't pause. So what we found were some encouraging preliminary signs related to student-centered instruction. And instead of thinking of student-centered teaching as a monolithic construct, we identified some concrete entry points for teachers who may want to become more student-centered, but may not know where to start. What we're doing now with the Carnegie Foundation for the Advancement of Teaching and the Nellie Mae Foundation is we're trying to build continuous improvement network communities. I think this is really exciting and promising, where you get researchers and practitioners together to form these networks to identify common problems that they want to solve, agree on measures that they can use to assess progress, and then share what they're learning, and to apply rigorous science to the classroom in a collaborative way. Carnegie's model is not unique. It's the Plan, Do, Study, Act model, which those of you that have read about the Japanese auto industry and some of the continuous improvement approaches that have been used in that industry, it's basically how do we understand this problem that we're trying to solve? How are we going to accomplish the solution? What changes or interventions need to be introduced to see if there is change? And then how will we know if it made a difference, which is a really important question. Then over time, building these network communities, as you plan, do, study, act, you can, in theory, make incremental improvements towards solving these complex problems of practice, which math teaching is, especially teaching for understanding. The challenges of building these networks are real. Trying to identify a common problem that we all agree on is a first step. Being able to measure that our kids are progressing in a certain way, we have to agree on common measures. And we can't disrupt the challenges of the classroom and the burdens that are there. It has to be practical, these communities. But I think that the opportunities outweigh the challenges, and I've seen across the country some amazing examples of teachers who are hungry to participate in these network improvement communities. They're ready to sign up, try things, test them out, report back, and make these incremental improvements. So that's what I'm excited about related to the research and practice. And that was way too much to do in 20 slides. So thank you.
All right, thank you, Kirk. Our last prize tonight is a geometry ball. If we could see the picture of it, this is an inflatable ball, and what it is it's got different sort of answers to definitions, and the way you use it with students is you stand in a circle or in any more than two people, and you throw it to them, and wherever their left thumb lands, it'll say complementary angles, and you have to give a definition. Or if you toss it to someone else, they catch it and it says 2L plus 2W. What is that the definition of? And so it's a way to do some kinesthetic studying of geometry topics. It's an even better way to recruit kids to your sports teams. And so for you coaches out there, this is for you. Our winning number is 116. All right. Okay. Before our last speaker, I want to give a huge thanks to Math for America DC and the Carnegie Institution for Science for hosting us tonight. They've been really gracious hosts, going above and beyond with all the preparation it took to get this event going this evening, and for providing this beautiful space that Maxine told us about earlier. Thank you to Carnegie building staff for preparing the space for us, and to John Strom for being the videographer for the evening. All of your efforts are really greatly appreciated. I also want to give a couple of thank yous to Julia, our designer of our MFA Ignite 2 logo, using her graphic design skills. She's a fellow Math for America, with Math for America, and teaches at Capital City. I also want to thank Mark from ProAV DC for running all of our tech tonight. He's been great to work with and has kept us running at a good, quick pace. Finally, we'd like to thank Maxine Singer for her leadership in bringing Math for America to Washington, D.C. We'd also like to thank Marlena Jones, Monica Thomas, and Bianca Abrams for all their hard work they do in running Math for America throughout the year and starting to build this big network of people who love teaching math in DC. We really appreciate all your efforts and for bringing all of us together tonight. So a big round of applause for them. So our last presentation tonight is from Rachel Crouch. Rachel teaches at Center City Public Charter School, and when asked about her favorite snow day activity, she said, watching TV and eating ice cream on my couch, which I think struck a chord with me when I heard that one. Rachel's presentation is titled Teaching Perseverance. Let's give a warm round of applause to Rachel.
Thank you, Will. All right. Hi, everyone. I'm an assistant principal at Center City Public Charter School, the Brightwood campus in Washington, D.C. And today my presentation is on teaching perseverance and what does that look like inside of the classroom. But before we talk about teaching perseverance, we have to talk about the opposite of perseverance, and that would be the next slide. Okay, thanks. And that would be learned helplessness. So if we're teaching perseverance, what we're trying to do away with is learned helplessness. So what is learned helplessness? You've been inside of a classroom where you are teaching at the board, you're doing your I do, everything's going great, and then as soon as you turn to the we do, you get this. There are a subgroup of students who say, help, sit there and wait for you. You never taught this, I don't remember this, and it's not everyone, because some of the kids just started on their own, some of the kids are trying it on their own, but there are some who will wait for you and wait for you to come help them. And that's when we become unintended enablers, because we unintentionally help them, but it's not helping them, right? So we help them because we feel sorry for them. They're behind. They came to us 5 grade levels behind. What are we supposed to do? We have to help them. They're behind, and we want them to keep up with the classroom, when actually helping them is not helping them keep up. And it's easier and less time consuming. You don't have to scaffold lessons if you just run over there real quick and jump in to save the day. So the good thing about that is learned helplessness can be unlearned. And then how do you unlearn learned helplessness? So we talk about students not being able to do work independently, but the only way we can get students to start doing work independently is if we create the spaces where students have to do work independently. We have to require students to do what we want to see them do, what we think they can do, what we believe they can do. So we have to require them to work independently. So that means when they raise their hand and say, I need help, ask 3 before me. There are three other kids at your table you can ask. Or what are some steps you can take by yourself to figure it out before you get to me? And also, what have you done in order to start the problem without me? And then just simple nudges. I know you can do it. You don't need my help. Try it by yourself. You know, that goes a long way with students. And granted, that's taxing, because then you may run into some behavior issues. Students get frustrated, and too many students frustrated means the teacher is very frustrated. So you stray away from too many students being frustrated, but stick to your guns. I have confidence you can do this. Let me help you. Let me watch you get started, not help you. I'm going to stand right here and watch you. And it's so hard as educators to watch and not talk, watch and not help, because we always want to jump in and save the day. But giving them simple prompts and suggestions. Don't overthink it. I know you can do it. You can do this. Trust yourself. I believe in you. Are small things we can do to get kids from learned helplessness to perseverance. So mathematical practice standard 1 in the kid-friendly language is I can attack a math problem and persevere in solving it. And it's so important that we talk to our students about persevering through problems so they understand what we're doing and why we're doing. Everyone in here knows the hardest thing for kids to grasp are multi-step problems. You give them a problem that has an A, B, C, D, or not even an A, B, C, D. You give them a problem that's too long, they start to struggle. Why? Because it's 2015, everything's a click of a button. And they can just raise their hand real quick and the teacher can just lay it out for them. But we have to let them think. We have to teach them to think. Oftentimes when they come over, we start thinking for them, doing the process for them, and they give us one-word answers, and we're like, right, put that on your paper. But they didn't do any of the hard work. We did all the hard work for them. So some simple steps. Talk about the power of attitude and perseverance with your student. Have them show grit. Show grit all the time and use that language in your classroom so they know that's what you expect of them. Turn the problem into a picture or a puzzle. All of us in college, for all the people who majored in math, I did, and it was not the easiest thing to do, but every time I started a math problem, I drew a picture to help me. And every time I have students start math problems, I have them draw a picture and make it visual for them, because our kids are visual learners. And this is the one that's most important. I should have made this 3 slides, but scaffolding assignments. Starting with smaller problems that they can solve to put wins under their belt. Everyone should have an access point to every activity. That could reduce the amount of hands being raised and the amount of people in your classroom who feel they just can't start the task without you. And then share the why. What is the hook? Why is this even important? Why should I even try this, and why is it important? I know it's important to you because this is your job, but what makes this certain activity, especially in math, important to me? And then one thing kids love to do that drives us all crazy is talk. They love to talk all the time. When we're talking, when we're not talking, they love to talk. So let's create the spaces so they can talk. So if students are struggling, they can talk to each other about it. And then lastly, just teaching grit. Teaching students to show grit and expecting that in your classroom. Showing grit is the way that we are going to pass state tests. It's the way they are going to be critical thinkers. It is the way they are going to learn to work hard to solve a problem and persevere while doing it. Thank you. That's my time.
Okay, thank you, Rachel, and thank you all for coming out tonight. We'd like to invite you all to have cookies with us in the lobby afterwards and meet some of the folks that you saw speak, meet some other folks that you've seen across the room. It's been wonderful to have you here. Let's give one big round of applause to all of our speakers one more time for coming up here. Thank you all for braving the snow to come out tonight. We know that it was not always the easiest to get here. We're going to send a short feedback for any thoughts you have on the event and to try to get some folks that are interested in giving. We are going to do another Ignite 3 to kick off the 2015-2016 school year in August. And so we'd like to gather some other folks to come up here and talk and have you spread the word to other colleagues so we can continue to get more and more people in this community of math teachers in DC. So thank you all for a great evening.